data from the Twitter. We are not actually concentrating about the regular database thing and putting the data into the database and querying from it. So where did we get the idea? This was actually not our voluntary idea. We had to do it because of the data mining course, but we voluntarily choose to do it on the radio procedures. And also the idea came from the hackathon. It's a conference which goes in all the based on the rare diseases every month. So we attended it and we got the idea to do rare diseases. We are actually implementing these three functions in our project. It's like we'll be retrieving the most tweeted user of a particular disease. We are going to get a set of queries for each and every disease, like if it related to their symptoms or the keywords related to the disease or something. And we are going to get the user who tweeted the most about this disease. And the second thing is like we'll be getting the disease which is more popular. That's based upon amount of the data present about the disease in the Twitter. It's again we are doing the same thing over there. We are querying regarding the keywords of the disease and something like that. And the third one is like we are going to get the most related tweets which has the more information about the particular disease. So these three are the functions which we are going to implement in our project. Actually, we have planned to do the Android application in Python, but we haven't got any particular assistance about it, like how to implement the Android application in Python. We only know how to implement the Android application in Java. So at this point of time, we are actually going with the web application. We are doing all the data collection and the algorithm thing in Python, but we are doing the UI interface using JavaScript. We are going to explain that in detail in the next slide. So how does the data collection do? So we are told that we are collecting the data from the Twitter. How does that happen? Like usually, as you people may know, like the Twitter gives the developers access to the data. If we ask them for an authorization, we'll be giving the authorization keys, the consumer key and consumer secret, where the Twitter allows us to access the data from the Twitter. It also allows us to access from the user streams, the public streams, everywhere. It has three kinds of APIs, usually the search API, REST API, and the streaming API. Most of the used APIs are the REST API and the streaming API. This is because like the REST API, we are actually using the REST streaming API to implement. It was suggested by a professor to use that. The main difference between the REST and streaming API is like the REST API is if you query about the disease. For example, if you put the keywords and query this data, we'll be getting the bunch of data, like related data in the tweets. It doesn't go with the time constraint or anything like that. Whereas coming to the streaming API, it's different. Like if you query the Twitter on the streaming API, it gives the latest tweets, like the tweets which are latest in this particular time. Like you can, streaming API on the backend, it continuously keeps on interacting with the Twitter and collects the data and gives the user, whereas the REST API, we are only able to do the one time. And that's the difference between the main thing. And how we are going to filter out the data. All the tweets which we get from the queries are not related to the diseases or all are not related to the data which we want. So what we are going to do is like we are going to do the recall and the precision thing, which determines the quality of the data which we have retrieved and which determines whether the data is particularly related to the thing which you are implementing or not. And further we are going to, if it's depending upon the recall and the precision, then we are going to change our query process, or we will think if we want to implement further more or something like that. And we may also include the geolocation based on some of the tweets so that we can get if the disease is prominent in particular area, so that we can get the more kind of information in a particular area. So we may also include the geolocation, which is possible through using the streaming API. So this is the data collection part, and the algorithm part will be different.
So to go more into how the actual system works, we'll be making use of two tools to help us figure out how to organize and classify the data. First tool that we will implement to organize our data is SVM, also known as support vector machines. What support vector machines are is that they're a classifier that allows you to separate data into positive and negative data. That's mostly done based off of the user's choosing or the person implementing the support vector machine. The main thing that using this support vector machine will be able to help us do is it'll help us create weights, which I'll which will help with the next implementation step, which I'll get to in a bit. But the main idea is that, when you're searching for data for a rare disease, there's symptoms associated with the disease, and there's just random stuff that might not be associated with the disease at all. It just happens to get together in your query. So you have, you want to separate it into positive and negative, and that's, how you would go about doing that. So the second step of implementation that we'll be using to help organize our data is using probabilistic soft logic, also known as PSL. PSL is the real backbone behind what really organizes the data. Because what PSL essentially does is is that it's an automated way of making guesses about how related something is to a certain topic. So the idea is that with PSL is that you have a weight and some other factors that go into it to let you be able to determine how closely related something is. Like in general, in our case, what we're working with, you want to be able to determine how close a tweet is to actually talking about a disease. So you have with PSL, you have different the way that you work with PSL is that you have rules, and you use these PSL rules to find associations between diseases. And the general idea behind what the weights are that you calculate with SPM is that a certain topic related to a disease a certain symptom might be more common than another symptom. So even if you use the same rule set with something, you want to have a certain weight added onto this disease to say, okay, this is more likely to be talking about this disease than another disease. Then Trey will go over the actual user interface.
So you guys have listened to the boring stuff. So that is the cool stuff. Because I'm a UI designer, so I make cool things, basics of the cool things in the back end. So you have seen the PSL, so our application actually predicting what the tweet is about. So initially we tried to make an Android app. So pretty much for all the mobile app you have seen today, we want to put the lot of information into a screen like this big. So we have graphical data, we have quantity data, and we have informations. So, and when I think about it, I don't think this is a good way to do it. So now that we're not doing a mobile app, instead we're doing a website. So let's take a look at a website. So this ones look like a traditional website. And it gives you the same information about everything that we just mentioned before. But it's more well organized, and you can access from the desktop. And what happens to the mobile? So once it turns to a mobile, we use a responsive design that if you're building it from a smaller screen, it's going to collapse to just a single column. And even though it captures a single column, but we will still have 4 features. So all the features are compact to this thing that I call the X-way. So for the keywords, mentioning tumors and PD, is a gene, and sleep and stress. We have the PSL rule, so we know that how relevant this information in the tweet relates to the rare disease you are looking for. So it's like, so when you put a tweet on the left side, there's a tweet there. So based on the keywords inside a tweet, we can calculate. In this example, it's like 80% is talking about the Pavani syndrome. So it gives you a sense, it gives you feedback first, what And then we also have interactions. On the right side, you can see in the tweet you mentioned brain tumor. So if a user, already a professional educated personnel, they can, they can see those things and they can improve those. They can improve our applications by adding the brain as a keyword into the PSL. So over time, it improves the quality of how the application predict what people is talking about. Are they really talking about the rare disease you're looking for, or that tweet is just talking about something else that you don't want to? And also, if it comes to a single column as mobile view, you get the same thing, and we highlighted all the positive keywords in red and all the negative in green. And you also have interactions, unlike desktop versions. We want to make it easy, so you have the thumb up and thumb down. So if the user can see the result, see the feedback, they can actually improve the application by just saying, I agree with the prediction, or I don't agree with the prediction. So over time, again, you will improve PSL rule that we have in the background, and it's actually the machine will learn how to do it better and better.
So what we have, we actually, as I told, like we first thought of implementing it in Android, but we are not doing a better situation. So what we actually initially thought of, like we will include a certain kind of database functions, like we also thought of including where the disease originated from and what are the real symptoms of the disease and what the articles on the present articles on the disease and stuff. But so we are purely concentrating on the data mining. So presently we are not doing any database stuff. We are only doing the getting the data from the tweets. And we are concentrating on a particular two diseases like kind of a PTN and Alzheimer's. At this point of time, we are not going further. It can every time be upgraded. We can once we implement the thing, so adding the diseases could be more easier. So we are first doing it on a PTM, which is a very rare kind of a disease. Whereas in Alzheimer's, it's a common kind of a disease, so that we can get most data on it. So we are experimenting on two different kinds of diseases. That's what.
So for your database, what are you going to use for that?
We are not using any kind of database at this point of time. We are just collecting the tweets.
Okay.
And we are putting these tweets into the SVM so that we can get the weights out of it, and we are putting these weights into the PSL so that we are getting the actual output which we need. We are not actually using any kind of a database right now. We are just concentrating on tweets output. We are just putting the tweets into the text and we are getting it from there. We are importing it to the JSON object. So,
Right. So for your project, you don't have to do this with the database and everything?
no, we are our professor wanted us to concentrate on data mining.
Just the mining part,
Yeah, so we didn't actually.
So what does PSL stand for again?
Probabilistic soft logic.
Okay, and how do you transfer like a word to like you just record like how many words are associated with like a certain disease, or how do you start to make math?
Okay, so with PSL, what you would do is that first you have to have like an idea of the kind of you have a disease, you have the symptoms associated with it, and you assign that a ranking, and then you give it a weight. And the weight you could use based off of calculations with support vector machines. So once you have that, it creates essentially a probability of it being associated with the disease. Because the main reason you're supposed to use PSL for is that it's an automatic detection tool for reading in data and like associating it with something. So in this case, you give it a disease symptom, and it tries to see how close it is to the actual disease that they could be talking about, or something similar to that.
And do you like map like several words to like perhaps one symptom? Like if you have words for the same thing?
Like if they're synonyms of each
Like if
other?
there's synonyms and stuff like that.
Yeah, you could probably, if they're synonyms and they mean like the same thing, you could probably assign both of them the same exact ranking and weight. And that would probably be a good idea to keep in both of them, and just assign them to have the same rule, really. That kind of thing would probably be.
Do all the weights like update in real time, or is it like something you run like a batch maybe every day?
That's like something we haven't really gotten to thinking about. Symptoms aren't really something that change very often, so you probably wouldn't want it to run like very often, as opposed to less often, because that would be inefficient. I explained that.
Yeah,
you don't want it to
that
run
makes sense.
too often.
What about like when you're starting off, like say you haven't put the, you just say designing the system, put it out like 2 months from now, but you want to assign all the weights. Is there a way to like look at the tweets back from the last 5 years so you have enough data to?
I don't know how far back you can get tweets from. Like,
Only 3 months. We can only query the,
Only 3 months.
yeah, we can't go to the back of that. And we can only get 3200 kind of tweets using streaming events. So we are just concentrating on the data which we get, so that like we can put the users who tweet about the particular disease more frequently, and the data which is more present about the disease in the Twitter. So that's what we are actually concentrating.
and the reason why we focus more on users who would tweet a lot about a disease is because we would assume that if they're talking a lot about it, that they're trying to either A, help awareness, or they're B, very knowledgeable on the subject. Parts of that go back to the original design when we first came up with the project, but we had to cut down on our ideas because most of them were school and we had all these things to be working on.
But it's surprising.
Yeah. So, any more questions?
Do you have like an idea of how you find like the say you need to find someone with a certain disease? Would you like actually search Twitter for them, or do you try to get hooked up with them through the hospital and ask them things about the disease and get like an idea of what kind of terms?
Since from a data mining perspective, that's probably that's an interesting thing to think about, really, because mostly we thought about just analyzing Twitter for the moment. What you're thinking of, I don't really know how to think of it with like an automated method, because that just seems like something you manually look up yourself. Like for some of the diseases we have, like obviously for the symptoms, I mean you could just pull them from some kind of database already, but you'd still have to manually look them up, find them yourself. So in terms of actually finding someone who could have a rare disease, obviously you could look through Twitter and see if like some news agency is like tweeting about someone having this disease and find it from that. But otherwise we probably have to expand the implementation to being some kind of like web script, or just like looking through various news websites and seeing what comes up there.
Can you explain, when you say rare diseases, how you, what you class, for your purposes, how you classify it as a rare disease? I just was wondering what.
It's not usually frequent kind of a fever or a kind of diarrhea or kind of things which are not usually frequent, and the things which don't have much information about, which we don't know about. Like usually there is an organization called NORD, NORD, which is a national organization for rare diseases, which states there are about 7,000 rare diseases at this point of time. So we actually consider those diseases as rare diseases and picking up some of them and doing the query on that.
You mentioned how your SVM separates your data between positive and negative results. How does it decide which tweets are positive results and which are negative?
That goes down to for a rare disease, like you want to you have keywords for when you do the queries, and you're gonna search for a tweet and like, you know, get queries related to that. Like for a more general idea of like what a negative query would be, like let's say you're looking up traffic data and you just like, so one of your queries is car, but all it does is like return something like, oh, like I got a new car. Like, you know, that's gonna return in your queries, but it's not gonna be related to traffic. So that would be a negative tweet, so to say. Well, you know, if you're getting like actual traffic data saying like, oh, there's a car accident like here, that would be a positive tweet. So the same kind of idea just carries over with how you would classify positive and negative tweets there. So, you know, you look for diseases. If something comes up and it has like symptoms or it's like, you know, related to the disease you're working with, you know, you do that. Otherwise, you know, you with a negative tweet with diseases and stuff, you could search like a common symptom like, you know, like headache or something and get some disease totally unrelated to what you're working on. That would be